So we're looking at the Math 2 Unit 4 review worksheet. First problem that we have, we're looking at DE being a mid-segment of triangle ABC. So we have DE as x plus 5 and CB as 3x minus 1. Now we don't want to set these two equal to each other because it's a mid-segment. So what this means is that 2 times DE is equal to CB, or that DE is 1/2 of CB. So we have to either take half of the longer side or double the mid-segment. Now it's going to be easier to double the x plus 5, so let's do 2 times x plus 5 equals 3x minus 1. We get 2x plus 10 equals 3x minus 1. We subtract over the 2x, we get x minus 1 equals 10, and x equals 11. For the next one, we have DE as the mid-segment again, but this time AD is 15, and AE is 14. We need to find AB. Now AB is the mid-segment that includes the 14. We know E, because of the mid-segment, is a midpoint. So we have 14 and 14. So AB is going to be AE plus EB, which is 14 plus 14, or 28 units. For the next one, which group of side lengths can we use to construct a triangle? So for this, we're going to say that the longest side has to be less than the sum of the other two sides. So if this is true, then it makes a triangle. And it has to be less than, not less than or equal to, as we look at it. So for this, we're going to get 15 is less than 13, 5 plus 8. That is false, so no, not a triangle. For B, we get 20, its longest side, is less than 10 plus 12, or 20 is less than 22, so that is yes. That makes a triangle. C, we get 25 is less than 10 plus 15. 25 is less than 25, that is a no, not a triangle. That is false, it can't be equal to, it has to be less than. Last one, 18 is the longest. 18 is less than 2 plus 15. 18 is less than 17 is false, so that is not a triangle. For number 4, we need to list the order from the shortest to longest sides in triangle ABC. So first off, we have the angles. I'm going to list the angles first from shortest to longest. So I have angle C, angle A, and then angle B. So that is short to long. Now what's easy about this is the opposite side to the angle is also the smallest value. So opposite to C is AB. Opposite to A is BC. And opposite to B is AC. And what's really easy about identifying that is the side that's opposite to an angle is the other two letters that make the triangle name. So if C is the angle, A and B make the side. If A is the angle, B and C make the opposite side, because if they're opposite of each other, they don't share a point. So this gives us our list from shortest to longest. For number 5, we're given two sides of the triangle. We need to find the possible lengths of the third side. So this is where we do the difference and the sum with the third side between them. So we're going to do 41 minus 23 and 41 plus 23. Well, this gives us 64, and 41 minus 23, I believe, is 18. That is 18. So we get that the third side is between those. Now we have to be careful. That doesn't mean it's 18 and 64. It's between 18 and 64. So if we're talking about whole numbers, it's 19, 20, 21, all the way up to 63. It could be even the decimal values next to 18 and 64, but it can't be those values exactly. For number 6, we need to match the line with the correct description. So we have perpendicular bisectors, angle bisectors, medians, and altitudes. So from a midpoint to the opposite vertex. So something that goes from a midpoint to a vertex. Nothing about perpendicular, nothing about the angle, and that's going to be a median. So that's A. Bisects an angle is going to be an angle bisector. Perpendicular to a side that goes to the opposite vertex, and then perpendicular line through the midpoint of the side. So our last two are very close to one another. So if I have a perpendicular that goes through the opposite vertex, it would look like this. But a perpendicular line through the midpoint would have to be labeled. Now a perpendicular bisector is both perpendicular and it bisects the side because it's to the midpoint. So that's going to be D, whereas the perpendicular to a side that goes to the vertex is going to be an altitude, and that will be C. For number 7, we're given that AE is a median in BAN. We need to find true and false statements. So I have AE as a median. That means that these two parts, BE and EN, are congruent because E is a midpoint. That's really all we know in a median. So if we look for BE and EN congruent, that's true. Now let's look at the other parts. AB and AN, not guaranteed to be congruent. We don't have enough information there. Angle B and N are not necessarily congruent, so we don't have enough information there. And BAE and NAE, now if it was an angle bisector we could say that, but this one is not enough information, so it's false. The only thing that's true whenever we have a median is at the midpoint. For number 8, we need to draw a segment that shows the altitude. Now the altitude is perpendicular to a side that goes through a vertex, the opposite vertex. So this would be our altitude. An angle bisector is going to bisect the angle, so we'll bisect angle X. So it goes from the angle and it shows these two parts are congruent. What it does here, we're not really sure. It doesn't really matter as long as it is bisecting the angle. A perpendicular bisector starts with a bisector of the side, so we're going to show a midpoint, and then it's perpendicular to that. So it's both perpendicular and a bisector. A median is like the perpendicular bisector without the perpendicular part. So it's just the midpoint, and that midpoint goes to the opposite vertex. I like to think of median like a road. You have that middle line in the road. When I draw it like this, it's almost like I have a road going off into the distance, and that middle line is the median. Now from here, we need to name the intersecting lines of the triangle and the point of concurrency. So let's just go with the order that we had up here. So I'm going to write altitude. Oh, got ahead of myself. We have the picture right there. So here's our 4 types. We're going to say for A, B, C, and D, the intersecting lines, so what makes it, and then the point they have in common. So let's start with A. On A, I have perpendicular and midpoints. So that's going to be a perpendicular bisector. Now perpendicular bisectors meet at the point that we call the circumcenter. Now it's also important to know that the circumcenter is equidistant to the vertices, but I think that comes up later. For B, if we look at it, it involves the angles or the vertices. It has nothing on the sides that's labeled or indicating. So this one is going to be an angle bisector. And angle bisectors meet at what we call the incenter. And this is just something you have to memorize. The incenter is actually going to be equidistant to the sides. So we draw them out. C, if we look on the sides here, I have lines showing congruence. So that's telling me a midpoint. So I have a midpoint at the sides going to a vertex. That'll be a median. And the medians meet at the centroid. And last, we have a line that goes to the vertex. It's perpendicular to the side. Does that all 3. That's going to be an altitude. And those meet at the orthocenter. Now for number 13, we need to find the measure of AD. So we have AD here is this segment. If I knew nothing about the rules that we talked about in this chapter, I could label this side reflexive and see that these are angle-angle side congruence, which makes these corresponding parts match. But this also applies to what we call an angle bisector theorem that says if AC bisects angle C here, these two segments, AB and AD, are equidistant, or it's the same distance to the right angle. In either case, we get 5x minus 3 equals 3x plus 1. It gives us 2x minus 3 equals 1 from subtracting 3x to both sides. We add 3 over, we get 4, and x equals 2. We need to make sure we read the directions, and it asks for AD, so we're going to substitute back in 3 times 2 plus 1 gives us 7, so AD is 7. For number 14, this applies to the perpendicular bisector theorem. So we have a line here, LD. It has a line perpendicular to it that goes through its midpoint. If it does that, then point T is equidistant to L and D. That is what the theorem says. But also as it relates to congruent triangles, I have side angle side congruence. That means that these two corresponding parts are also congruent. So I'm going to say 10x plus 7 equals 8x plus 24. If I subtract the 8x, I get 2x plus 7 equals 24. We're then going to subtract 7 over. We get 2x equals 24 minus 7, which is 2x equals 17, and x equals 17 over 2. So we have 17 over 2 here for LT. Now, or x, LT is going to be 10 times 17 over 2 plus 7. That gives us 170 over 2 plus 7 just by multiplying 17 times 10. And then we get 85 plus 7, or 92 for LT. Now if we did this correct, LT and DT should be the same length because they're equidistant, they're the same distance from T, they're corresponding parts. Which should though make sense, make sure that they work. So let's do DT, we'll fit it in here. We have 8 times 17 over 2 plus 24. I could do 8 times 17, it gives me 136, divided by 2 is 68, plus 24 gives me 92. So not the nicest value for x, but our segment length still worked out to be whole numbers. All right, moving on. Number 15, we have x is the midpoint of MN, y is the midpoint of ON, and z is the midpoint of MO, meaning I have mid-segments right here. So I need to first find xz. xz is parallel to NO. That means it's going to be half the length. So since that is 18, we're going to put 9 there. xy is 10. We need to find MO. So the opposite of what we just did, we're going to double 10 and make that 20 for our length. We now have that NO is 18, MN is 13. We need to find MX. So really the NO being 18 doesn't help us at all. To find MX, we're just going to take half of 13, which is 6.5, and that's actually both of the parts, so MX is 6.5. Next, for number 16, we have a 2x and a 3x minus 5. I don't know how clear your copy is here, but these are congruent parts. We can match them with reflexive property and see that the two triangles are congruent. This is also the perpendicular bisector theorem, but I get 2x equals 3x minus 5. We subtract over a 3x, and I get negative x equals negative 5, or x equals 5. So we'll put that there. TW is going to be 2 times 5, or 10. And WZ is going to be 3 times 5 minus 5, or 15 minus 5, and also 10. And they should both be the same value because they are corresponding parts in our congruent triangles. For number 17, we need to find the value of x when we have the angle bisector theorem. So we're going to go 7x plus 3 equals 10x minus 9. We subtract the 7x over, and we get 3 equals 3x minus 9. Add the 9 to the other side, and we get 12 equals 3x, and x equals 4. They're just asking for x here. I do not need to substitute back in, so my answer is 4. But I could check. 7 times 4 is 28, plus 3 is 31. 4 times 10 is 40, minus 9 is also 31, so the values do work. For number 18, which is the smallest angle in MNO? The smallest angle is opposite the shortest side. The shortest side is 17, so opposite to that would be angle M. We could also name it with 3 letters, NMO, or angle OMN. All 3 would work. For number 19, we need to list the order of the sides from shortest to longest. So let's list first the angles from shortest to longest. It goes angle F, angle E, and angle D. The side opposite to that will be the other two letters. So the other two letters to F would be DE is the shortest. E we have DF, and for D we have EF. So shortest to longest is that list. Now for 20, part A, B, and C, we need to work with two triangles to figure out what our shortest segment is. We have to be careful how we do this, because the smallest angle total does not necessarily mean it is the shortest segment. So the first thing I'm going to do is I'm going to find my missing angles. So I have 48 and 85. I'm going to add those together. That's 133. I'm going to subtract that from 133 and I get 47. I am then going to look in this triangle. I have 52 plus 61 is 113. 113 from 180 is 67. So I found all my angles. Now here's how I'm going to find the shortest one. I'm going to list them like I did up here and compare the differences. So for this triangle here, if I went shortest to longest, 52 is opposite DG, so that's the shortest. The next one is 61 is opposite DE. And then the last one is opposite the 67, so that's EG. In the other triangle, the shortest is opposite the 47, so that's EG. Then we have the 48 is opposite GF. And lastly, the 85 is opposite to EF. Now here's what happens. When I look at these two triangles, EG is the same side in both triangles. In one of them, it's the largest, in the other one, it's the smallest. So let's say that EG is 10 inches. If it's 10 inches, it is the largest side in this triangle. If it's still 10 inches down here, it's the smallest in this triangle. So that means if it's the largest here, these have to be smaller than 10, these have to be larger than 10. So it's going to be guaranteed that DG is the shortest side. So we're going to do that same idea again for this problem, and let's see if we can kind of see where it's going. So first I have 61 and 60. That gives me 121. 180 minus 121 is 59 degrees. Then we have 65 and 55 is 120. That's going to give us 60 degrees. I'm going to list them in order again. So in this triangle, the shortest, 59 is opposite DC, so that's first. 60 is opposite AD, that's next. 61 is opposite AC, that's the largest. For the other triangle, I'm just going to write it right underneath. 55 is the smallest, that's opposite AC. 60 is next, that's opposite BC. And 65 is last, that's opposite AB. Now I'm going to look for what they have in common, and they have common AC. AC is in both. AC is the same length. So everything in this triangle is smaller than AC. Everything in this triangle is larger than AC. So that means DC is the shortest overall. Last one. We got 82 and 25. Gives me 107. 180 minus 107 is 73 degrees. 87 and 23 is 110. 110 from 180 leaves me with 70. So we have this triangle. Shortest is 25 is opposite to AB. 73 is opposite to BC. 82 is opposite to AC. Next triangle, 23 is opposite to BC. 70 is opposite to CD, and 87 is opposite to BD. So what do they have in common? They have BC in common. So I know everything over here is larger than BC. The only thing shorter to BC would be AB, and that is our shortest side. Last page, number 21, we have two sides of a triangle are 5 and 10. What is the range of the third side? So we're going to do 10 minus 5 gives the bottom end of the third side. And 10 plus 5 gives us the top end. So we have 5 and 15. So we're going to say that the third side is between 5 and 15. So again, whole numbers, 6, 7, 8, 9, 10, 11, 12, 13, 14 does not include 15, does not include 5. It's all the values between them, including decimal values. For our last problem, we're going to use these coordinates, and we're going to go through and show our mid-segment theorem proof with the coordinate proof. So let's plot the points first. I have A is -2, 3. B is 0, -5. And C is -4, -1. I'm going to connect them here. Okay, so I plotted the points. First step done. Now I'm going to find and label the points for the graph for coordinates D, E, and F, which are going to be the midpoints. So the first thing I want to find is the midpoint of AC, and that's going to be point D. So point D is the midpoint of AC. So for the midpoint, I'm going to add the x's, -2 plus -4, and divide by 2. Add the y's, 3 plus -1, and divide by 2. -2 and -4 gives me -6/2. And 3 plus -1 gives me 2/2. So we get coordinates of -3, 1 after we simplify the fractions. Now if we look, -3, 1 is actually the midpoint. We did it correct. So that's point D. D. Next we're going to find the midpoint of CB, which is point E. So CB are these 2 points. We're going to go -4 plus 0/2, because those are our x values, and -1 plus -5/2, seeing that those are our y values, -4/2, and -6/2 are the values we get. These simplify to be -2, -3, and if we plot that point for E, it is the midpoint. So next, last one we have here is the midpoint of AB, which is point F. So A to B, we're going to do -2 plus 0/2. That's the x values. And 3 plus -5/2, giving us -2/2 and -2/2, which gives us coordinates of -1, -1, which is F. Let's write them all in. And E was -2, -3. Now we could connect these points, and that gives us our 3 midsegments. So next step, we need to show the slopes, or show that the slopes are of each midsegments is parallel to their sides. So I'm going to work in the sets. So I have DE and AB. I have DF and CB, or BC. And then I have EF and AC. So each of those is the midsegment and the side that it should be parallel to. So we're going to do the slope of DE. So from D to E, slope formula is the change in y over the change in x. So from 1 to -3, my y value went down 4. From -3 to -2, my x value increased 1. So this is a slope of -4. The slope of AB, my y value went from 3 to -5. So it went down 8. My x value went from -2 to 0, so it went up 2. Negative 8 over 2 gives me negative 4. So because the slope of DE is equal to the slope of AB, we know that DE is parallel to AB. Next, DF and BC. So the slope of DF, it's change in y over change in x. D to F. I went from 1 to negative 1, so that went down 2. I went from negative 3 to 1, that went over 2, gives me a slope of negative 1. The slope of BC, change in y over change in x. We went down from negative 1 to negative 5, so down 4. We went from negative 4 to 0 over 4. Negative 4 over 4 is negative 1. So the slope of DF is equal to the slope of BC. So we'd say that DF is parallel to BC. Last one, EF and AC. From E to F, our y value went from negative 3 to negative 1, so it went negative 3 to negative 1, it went up 2. And then from negative 2 to negative 1, that increased 1, so my slope is 2. From A to C, my y value went from negative 1 to 3, so it went up 4. And my x value went from negative 4 to negative 2, so it went over 2, and I get 4 over 2, which is positive 2, which tells us that the slope of EF is equal to the slope of AC, so EF is parallel to AC. So we showed parallel with slope formula. If their slopes are the same, they are parallel. Next, we have to do the distance formula to show that each midsegment is half the length of its side. So I'm going to steal the categories I had before. I need to show that DE is equal to 1/2 AB. I need to show that DF is equal to 1/2 BC. And I need to show that EF is equal to 1/2 AC. Now, I could use full distance formula here, but I'm gonna use that the distance is the change in x squared plus the change in y squared, which is very close to Pythagorean theorem, kind of helps it a little bit easier to find the values, instead of doing the x2 minus x1, y2 minus y1. It just gets too many things. So I'm just going to count the values. I want to think of this as triangles. So let's go with DE first. So D to E. D to E, my change in x, I'm looking at right here. It changed. My x value changed 1, my y value changed 4. So I'm going to say the square root of 1 squared plus 4 squared. That's 1 plus 16, which is the square root of 17. Now AB. A to B, it changed 2 here, and it went from negative 5 to 3, so it changed 8 here. So 2 and 8. So for AB, I'm going to do the square root of 2 squared plus 8 squared, which gives me 4 plus 64, which gives me the square root of 68, which at first look doesn't look right, because 17 and 68. What you could do is look at what their decimal values are. So the square root of 17 is 4.12 approximately. And then the square root of 68 is 8.24. So that actually shows it's doubled, so we could say that it is about 4.12, and this is about 8.24, so it does double in length. The other thing we could do is we could simplify this radical. The square root of 68 is 4 times 17, but the square root of 4 is 2, so it becomes 2 root 17. So because DE is equal to 1/2 AB, if I took half of AB, or half of 2 root 17, it gives me the square root of 17. So we could write DE equals 1/2 AB. DE is the square root of 17, is equal to 1/2 2 root 17, and we get square root of 17 equals square root of 17. So that shows that it works. Let's do that again with DF and BC. So DF df, let's see, it went 2 in the x direction, 2 in the y direction. Let's get on the screen. 2 in x, 2 in y. So we're going to go 2 squared plus 2 squared, or square root of 4 plus 4, square root of 8. Now the square root of 8 we can simplify, so that is 4 times 2, which becomes 2 root 2, because the square root of 4 comes out of the radical. For BC, let's look at BC here, it changes 4 in the x direction, 4 in the y direction. So now we're going to go 4 squared plus 4 squared, or 16 plus 16. We get the square root of 32. 32 is 16 times 2. The square root of 16 is 4, so that becomes 4 root 2. So now to show that this is true, df is equal to 1/2 BC. df is 2 root 2, is 4 root 2. Half of 4 is 2, and we get 2 root 2 equals 2 root 2. Last one. EF and AC. EF, let's see, EF is right here. It went over 1 up 2. So that's 1 squared plus 2 squared, which gives us 1 plus 4, or the square root of 5. For AC, it went over 2 up 4. So that's 2 squared plus 4 squared. 4 plus 16 gives us square root of 20. Now 20 is 4 times 5. The square root of 4 is 2, so that becomes 2 root 5. So we now have EF equals 1/2 AC, where EF is the square root of 5, times 1/2 AC, which is 2 root 5. Half of 2 we get rid of, so we get the square root of 5 equals the square root of 5, and it works. Now, things to keep in mind for a coordinate proof. It will work. Mid-segment theorem is an actual theorem, so it does work. So as you go through, and I realize it's a lot of numbers here, as you go through, it will work out. If you find that, for example, it doesn't work here, or the slopes don't match, it means you did something wrong, and you need to either go back and fix your coordinates, or fix the formulas, or make sure you've solved it correctly. But like any other proofs, they're not going to fail, they're going to work. What you have to do is show your thought process to verify that it does work.